Hello everyone, welcome to the webinar. Today's webinar is going to be on graph analytics for fraud detection. So we are going to talk about the role of graph analytics, basically graph technology in the space of fraud detection, which includes various different use cases and architecture. So moving on to the next slide, just a brief background about myself. I'm basically a technologist, entrepreneur, you can say, with almost like 18 plus year of experience in the industry. Mostly my focus or all my experience has been around data management analytics, which includes in my most recent experience, I've also worked on fraud analytics use cases. So I would be able to share some light on that. And overall, I know I've worked in many various industries, which includes financial industry, healthcare, banking, insurance, technology, and so on. Okay. Just a brief background about Inferyx. Inferyx is it's a global analytics company. We are basically helping enterprises like banking and insurance companies, like BFSI sector, to be more precise, in building AI applications, through our services and product. We have our mission is to empower as many enterprises as we can to do end-to-end data management and analytics on a single platform. Okay. So maybe if you're interested to learn more about our platform, our services, we can have you can reach us out at contact us or at inferyx.com, or you can look at our previous webinars or our website, which is inferyx.com, and you can get more details on it. So the agenda for today's webinar is we are going to take an overview of what is graph analytics. Then we will look at, what exactly is fraud detection architecture, like how a typical architecture looks like from a graph analytics perspective. Then we can look at, what are the use cases for graph analytics within the fraud detection space. And then we can look at one or two examples from the banking and the financial industry, banking and insurance, I'm sorry. And then at the end, if you have any question and answers, I'll be happy to take them out. So graph analytics, so basically it's a process of, graph is all about relationships, right? Like, so when you analyze, traditionally, when you try to analyze data using like some kind of data analytics tool, or let's say like a SQL engine, or maybe using some kind of reporting tool, dashboarding tool, or even machine learning for that reason. So the perspective is not about looking the data from a relationship perspective. So when you when you really want to go to the more advanced or the more sophisticated type of analytics to find the unknowns, to spot the unknowns, that's where graph analytics is going to help. If you are well aware about your data, let's say you're well aware about all the entities, the relationship, and the influence of those entities, with regards to the relationship, then I don't think so that there is any unknown left, because you know everything and you can go and model, and you can create a predictive model out of it and make the predictions, right? But so I would say graph analytics is more for an exploration, and then it starts with an exploration mindset. And then once you discover some patterns, some things which are unknown to you, then we can transform that into to the known world, which is like machine learning, and then make use and leverage into the outcome to the machine learning aspect, so that you can improve your existing models, your existing analytics process to generate new insights. Okay, that's really the goal of using graph analytics. Now, in terms of the nitty gritty of it, like what really composes of graph analytics is all about entities and relationships, right? So the circles that you see here, these are all called nodes. Nodes are nothing but they're representing entities, and the lines that goes between the nodes is called relationships. So what you really do is, like, as a part of graph analytics process, you take your relational data or whatever data you've got, and then you try to build a graph out of it. And graph is nothing but building nodes and relationships, or you can say nodes and edges. So relationship and edges are same thing. Nodes and entities are the same thing. They're just interchangeable terminologies. So once you bring your data, and there are various technologies out there which can be used for graph analytics. I mean, one of the most commonly used is like Neo4j, which is a database technology, graph database technology, which can help you pull the data from various sources and build this nice graph here, and then do the analytics by either running Cypher queries. Cypher is a language that is being used in Neo4j for querying your data, or you can also use the advanced algorithms, which is again included as a part of Neo4j product, which can help you to do analytics and generate insights or find the unknowns. So speaking about the algorithms, there are 4 high-level algorithm that I classified into 4 categories: uh, pathfinding, centrality, community detection, and similarity. So depending upon the use case you're trying to solve, the application you have, you will choose one or the other, or maybe you will use more than one. Um, but these algorithms are something that comes out of the box. It's not like something you have to write. You just need to know how to use these algorithms. Um, and since I mentioned about Neo4j, I will also mention about Spark graph library. So there is a graph library package also available within Spark, which is an open source framework, a distributed computing framework, in fact. So it is as powerful as Neo4j, but I would say like Neo4j is like fully focused on just the graph part. So they are obviously, much more stronger as compared to Spark. If you were doing something which is purely exploratory in nature, or like running an algorithm on your data which takes like a long time to process, then I would use something like Spark. And then if you want to do something more interactive in nature, then probably Neo4j is the right way to go. So pathfinding is all about finding the shortest path between two nodes or two entities. So taking an example of an airline, right? Let's say you want to travel from from A to B, which could be like from New York to London. And if you want to know like what are the various routes of flights available with different airlines, then you can plug in all that data in the form of graph. And then once you run this algorithm, you can exactly ask the algorithm that show all the shortest path where, and the shortest path could be, and you can also add attributes like, where it's going to cost the minimal. So you can keep some criterias as a part of your finding, and then based upon the finding, the results are produced. And then what you really come to know is the various shortest path from A to B. Now today in this webinar, we are not going to dive into the actual coding or the demo. The plan is to educate and bring everyone up to speed in terms of graph analytics and its role in the fraud detection world. And then we are hoping to have another 2 follow-up webinars, one from a banking perspective, another from an insurance perspective, that how graph analytics can help really in those areas. Okay, so there will be more action coming in the subsequent webinars. For today, let's just focus on the concepts and maybe 1 or 2 examples. Centrality is about finding the influential nodes. So this is typical in very like a social media network. When you look at a large social media network, which is nothing but a graph, you can find influential entities, which is nothing but the influential nodes, the nodes which are going to influence everything around it. So let's say there is a, like a political campaign going on, and as a part of that campaign, you see a lot of action happening, which means a lot of comments are coming across. People are, like commenting on each other. That means there is a relationship between those social media accounts. And if you want to find out that which account or which person is really influential in kind of, tweeting or socializing those that information, then you can use one of these algorithms, which will tell you exactly where is the concentration. So the concentration can be, all within a specific area. And then, based upon that, you can find it just doesn't have to be like one node. It could be more than one influential node. But the goal is to find out which are the influential nodes, because then once you come to know about those influential nodes, you can take some action about it. If I have to put the same thing in the context of fraud detection, since this webinar is about fraud detection, what can happen is like once you take all your account and customer and transaction information into a graph form, then you can run one of these algorithms, especially this one, which is the centrality algorithm, and you can try to figure out that which accounts or which locations are very influential when it comes to any kind of fraud pattern. So maybe you are already aware like these are the areas where the fraud has taken place, these are the accounts, but you're not pretty sure at this point that which account is an influencing account. Maybe in a network of accounts, there may be 1 or 2 accounts which are highly influential, which is kind of the center of the problem. And that is exactly what this particular algorithm is going to highlight you. The next one is the community detection. So community detection is all about finding groups or clusters of nodes. So here what you do is, now again, this can also be used for, many different applications. Let's say you have a large customer data, and if you want to create a communities of customers, who have similar interest or similar purchase history, and then you may want to recommend other products which are being purchased or used by other members of the same community, right? So what you can do is like once you have these communities, divided, then for within each community, you can run a campaign for all the products that are of interest within that community. If I talk from the fraud detection perspective, uh, you may want to find these fraud networks, right, which we also call it fraud rings. These networks and rings you can identify by using this algorithm, and then within that network, we know that, and this is purely based upon how you configure the algorithm. It's not like some magic wand that you're going to run it and it's going to produce the results. You have to apply some thinking while using these algorithms. But the point I'm trying to make is that these algorithms are available for you to use and apply, so that you can detect these kind of communities, the influential communities. And then within that community, you can further start drilling down and figure out, like, what is the area of interest, right? Like maybe you're looking for a fraudster, maybe you're looking for a customer who's very influential. So maybe you can, kind of connect with that customer and, ask to promote your products. There are many things that you can do once you know, like, how to group them together. Similarity is finding similarity in nodes. One example would be, like, there is a classic example like entity resolution. So let's say if you have large number of customer data, and all within these customer data sets, you might have some customers which are repeating or duplicate. There's no point of doing analytics when the information is like not accurate. So first thing you want to do is, like, you want to make sure there are no duplicate customers. You don't want, like, to lose the information. So for example, if you have one customer with some transaction history and another customer with another transaction history, and let's assume that both these customers are the same customers, you would rather want to have clubbed all these transactions together and then analyze, or whether it is for cross-selling purpose, or whether it is for improving the customer experience, or let's say even if you're trying to detect a fraud. There's no point of detecting the fraud if you're going to look at all this information disparately, right? You want to see everything holistically, so that you can do justice to your analytics and produce better results. So similarity algorithms, you can apply these techniques to find out the similarities between nodes based upon their attributes. And then you can make a decision that these nodes are the same nodes, and hence we should resolve them as a single entity. And then you can collapse it into one customer rather than two customers. Okay. So moving on. So let's talk about a little bit of the graph modeling. So we just understood, like, what is graph analytics, what is the role of a graph analytics in the world of, and what are the different algorithms, right? Now we can talk about the modeling. So first step, so obviously everybody starts with the data, but the first step is to do a graph modeling. If you're doing in a traditional world, you do a data modeling. In the graph world, you call it graph modeling. So graph modeling is all about, defining your nodes and edges. Like if you're given a data set, you should be able to identify the entities of interest, and then build relationships around them. So if I look at this very small example here, like this is a small set of data where I have account information and transaction information. So I have account information. I only picked like few fields because obviously we don't want to boil the ocean here, but just for you to understand the example, I have two accounts here, account number 123 and account number 1456. The first account belongs to Bob, second one belongs to Jane, and we have listed down their balances on their accounts. So given this table, I can say that, okay, we can have two types of nodes here. One is account and another is person, because account is account and person is person, right? There are two different type of entities. So the yellow represents here the person and the red represents the account. So since there are two accounts and two persons involved, altogether there are four nodes. Okay. So the first thing is to identify the node types and then identify the relationships between them. Okay. So now between the person, I don't have any data here to show where the two persons are connected. Maybe if I would have showed here, like, do they belong to the same family, then we would have drawn another edge between the two persons, like Bob and Jane, saying that what is the relationship. But right now, if you see here, between Bob and Jane, there is no relationship, since we don't have that kind of information in the data that is shown here. From a transaction perspective, you can see that we have, account number 123 has transferred some amount to 456, and hence there is an edge. So, and also obviously, these accounts belong respectively to Bob and Jane. So this particular account belongs to Bob, and this account belongs to Jane, and 123 account is transferring to money 456. So even the direction of the arrow has a meaning here. Your arrows could be bidirectional, they can be unidirectional, there could be no direction. So direction also carries a lot of significance here, right? You can bring a lot of context to the information, especially let's say if I was talking about airlines data, right? When you're having a flight that's going from, let's say, New York to Hong Kong. So obviously, if there are two nodes, New York and Hong Kong, there has to be an outward arrow coming out of New York pointing towards Hong Kong, because that's the direction of the flight. So that's how you can use the direction. If you're transferring money, that could be another way to utilize the direction. If there is a conversation going on between two people, and based upon who's commenting on whom, you can create a direction data as well. Right. So these are all the modeling aspects. You need to think about what are going to be my nodes, what are going to be my edges, how I'm going to name them. And you don't want to over engineer this. So ideally, if I want, I could have created even, let's say, an edge out of a node out of something which is non-relevant. A random thing would be to create a node out of dollar, let's say. So, I mean, that's not going to give any value to you. You're unnecessarily going to complicate the graph and create a lot of nodes and edges. And overall, it's going to impact your processing. So this is really about the skill and creativity that the more you understand about your business and the entities that you care within the context of your business, those are the entities which you want to create as nodes and edges. Okay. So moving on, let's talk about the fraud detection part now. We just covered the graph analytics and overview and how the graph modeling takes place. In the fraud detection world, there are many different methodologies that one can use. The most basic one is the statistical analysis, where you take the data of interest, like transaction data, account data, customer data, and then you do a lot of statistical analysis to come out with some kind of criteria, right? Like looking at the data by analyzing in a statistical way, you can infer saying that, okay, these are the things we need to look at and what should be the thresholds around that. So you kind of come up with like an upper and lower boundary for each of the variable, and then create some kind of rule out of it. So ultimately, the outcome of the statistical analysis gets fed into the rule-based models, which is nothing but also called rule engine, where you define these scenarios based upon the business context, whether it is a scenario for credit card or whether it's a scenario for cross country. It could be based upon the product and the nature of the transaction and also the geography. So let's say if I want to give an example of a rule-based model, it would be something like a cross-border scenario where you're moving money from country A to country B, and assuming that country B is much more risky as compared to country A. Hence, you want to see what money is going out to the risky country. So this is a classic rule-based example. Now you're going to look at the source and the destination of the transaction, the country, I mean, and then also you might look some additional things like, is it like a, is it like a blacklisted country or maybe like a sanctioned country? And also you can look at like, what is the transaction amount? So what I just described, like whether you're going to look at the country and what should be the level of risk, what should be the amount of transaction, all these is coming out, through the outcome from the analysis of the data that you have done in the first step, which is statistical analysis. So this particular approach, the only limitation is that if you have limited amounts of data, definitely one can, can do this in a very manual approach. And also the limitation is that, you can also only focus on certain variables, right? Humanly, you cannot go across every variable. It's very time consuming. And if you have to keep adjusting this threshold, that's a big downside to the rule-based models, because these adjustments have to keep happening, like, as the behavior is changing, like the behavior of the transaction is changing, the behavior of the account is changing. So in a dynamic world, I don't think so you can keep up with rule-based models. They are getting, they still exist in the production environment of a lot of banks, but I think like the future is really the machine learning, AI, and the graph analytics. That's where we need to focus. Now let's talk about some differences between like, machine learning, AI, and graph analytics. How exactly, okay. So talking about the machine learning and AI, right? So these are the next level of analytics that comes after rule-based is really machine learning. And here you use various classification algorithm like random forest, gradient boost tree, XGB, like, gradient boost tree, and then maybe, logistic regressions and so on. So there are many algorithms available on the ML and AI, which can be used for classifying your accounts or transactions to be fraudulent. And that's where you need all the label data. So one aspect of this particular process is you need to identify which columns are going to, or which variables are going to be of interest for training this model. Then you choose an algorithm, and then once you train the model, then the model can do future predictions for you. The only downside with this, so the upside, I would really say it is far better than the rule-based scenario, rule-based models, but it is still driven, and the downside is really that, it is kind of revolving around the features that one has to provide. So building the features is obviously a manual task, and one has to like be very creative in creating these features. Once the features are created, they can be fed into the algorithm, and the model can be created out of it. In terms of the graph analytics, now graph analytics is something I would not say is more advanced than machine learning and AI, but it could be very complementary to what you're trying to achieve. So the goal here is to predict the fraudulent transactions, or reduce the false positives. And the answer to this problem really lies into what you're looking at, right? You can look at everything that's available, from a statistical point of view, or all the variables that are provided to you. But then if you can go one step ahead and start analyzing this data in a very relational form, which is normally not possible if you're doing in a tabular form. So it's just a different type of analytics you're applying. And then based upon the insight that you generate from the graphical way, like graph analytics way, these insights can then feed back into the AI engine or your machine learning model, which can then like improve its accuracy, or it gets an additional piece of information to do a better job. Let me put it this way. Okay, so that's where really graph analytics comes into the play. It is really, if you reach a point where machine learning and AI just cannot improve any further, I would recommend that you start looking at graph analytics for additional insight, like trying to spot the unknowns, find the unknowns. Because when the unknown is known to you, then obviously you can make use of it in many different ways. This is a fraud detection architecture. So we spoke about. I'm not talking about the traditional architecture, which is the rule based, where we use a rule engine, etc. Here I'm talking more about what could be a future state fraud detection architecture. So let's say you have a source system which is sending data to your AI engine. So the piece in the center is basically the AI engine, this part where you will build your models and train the models, etc. But the major difference I'm trying to highlight here is the data that comes in that can go through a graph analytics phase. And during that phase, you can generate additional insight. And along with that insight, we can feed this into our feature engineering process. And also this can augment your investigation system. So if you see, like, if you want to do, obviously when you're generating the fraud, the intention is not to generate the fraud alerts and then do nothing about it, right? You want to investigate them to make sure that these alerts are legitimate alerts and take some actions, or inform the regulators, or the corresponding bodies. But to do a better job in terms of investigation, I mean, you can throw all the data to your business. They can try to analyze and see what are the reasons. But I think that if you can additionally augment them with the graph itself, which is nothing but looking at the data in a network fashion, right? Like who's connected to whom and so on. That can give an additional intuition to the analyst to do his or her investigation better, and get a better inference and make a better decision at the end of the day. Because the alerts that are getting generated through your AI system, they are not really, it doesn't mean that they are 100% correct alerts, right? It's just an alert. It's a probability of a transaction having a fraud, but whether the transaction is really fraudulent or not, that decision is made by analyst, which is on the extreme right here, the investigation system. So, so once your graph analytics engine provides the insight, these insights can then be fed into the feature engineering process. Additionally, the data that is coming in, that can also go into the feature engineering process, because you may want to leverage everything that's available to you and additional variables or insights that coming out of the graph analytics. And then once you build the features, then obviously you can train the model, you can tune, test. That is a very standard process, right? So today my focus is more on the graph part, like how graph analytics can fit into this architecture. So the goal was to show you guys where exactly graph analytics have fit in here. Okay. And also you can have like, I mean, this particular graph can feed both into your operational system as well as investigation system. So let's say you have a front office system, and maybe like, taking an example, you're trying to onboard a customer, right? So when you onboard a customer, there are a few attributes that you collect at the point of initiation. And those attributes can, I mean, graph can provide an additional insight, and which can help you make a decision whether you should really, what should be the risk level of this customer, what product should you offer, do you want to put this customer on hold, and things like that. Okay. It can also be used for other use cases. This is just one of the use case. Secondly, it has more, I would say, application on the investigation system, where once the alert is generated, as I mentioned, you want to analyze the alert effectively. Then you can also, create a hook between graph analytics engine as well as your investigation system. So that's the second application. And the third application is really the center part, which is the feature engineering, where you can extract information out of graph and then, put into feature engineering process, subsequently create a model, generate the alerts, implement the model, and then finally push the, because you can have different type of models, right? So you push this model into the outcome of the model, either into the operational system or the investigation system, depending upon what you're looking for. In terms of the use cases of the fraud detection, now, obviously, I'm just talking from the perspective of fraud detection. The graph as such can have many other applications, but today's the focus is fraud detection. These are all the areas where I think you can use the graph analytics to augment your fraud detection, right? To improve your fraud detection process. So one is like, detecting the new patterns. Like, what you have been really monitoring through your rule-based engine, or whether it is through the machine learning, those are already in place. That's not going anywhere. Now, if you want to take it one step ahead, then obviously you can look for new patterns. And to look for new patterns, you need a new way of looking at things. And that's where I'm proposing the graph analytics. You can look for using those algorithms that I was talking about, like the community detection algorithm. There are also some specific algorithms which are used called Leuven algorithm, which helps you detect these communities. And then once you detect the communities, you can drill down further into it. So these become additional patterns, to your existing process. You can also look for the influential entities like customer, organizations, locations. So taking an example of an insurance company, let's say it's a life insurance company, and you want to, detect, like, so there are many aspects in the insurance business, right? Like you have agents, you have employees, you have customer, basically the policyholder, the beneficiary who's going to benefit if there is a, once the policy gets matured, or, once based upon that. And then also, there is hospital, pharmacy, doctors. There could be an involvement of many different entities, and you may want to know what if, like, there is a fraud happening, from an agent perspective or a hospital perspective. So it could be very useful to use in those areas. The third is really the third one is augmenting the machine learning models, where you can generate these additional insights, nothing but features for your existing AI/ML models, and that can help you improve your accuracy and bring more information out of those models. The fourth part is more on the investigation process, where you can enhance your investigation process by providing this additional dashboard, which is driven off the graph engine, where the investigator can really navigate all the data, all of this data using a very relational aspect. The fourth is the real-time fraud detection. This is more on your operational system, where let's say you're trying to swipe a credit card, or if you are trying to you're trying to onboard a customer, and if you want to know some additional information based upon the graph that is already in place, then you can feed that information and try to do something in real time as well. That it's not like I would say I would put it like at the most bottom in terms of the usage, but there could be some possibilities for real time fraud detection as well. We'll end with, like, I have two or three slides. We'll just go through one or two examples, and then we'll end the webinar for today. And then, as I mentioned, like, we'll have the follow-up webinars. We are going to deep dive into the insurance space and banking space separately. So this is an example of a financial fraud. Obviously the color has a resemblance here. The yellow color represents an account node. The blue represents the person, like Bob, Jane, and Jim. Red stands for SSN number, credit card is dark color, and the green stands for address, and we have a merchant too. So there are many different entities, as you can see here. And in this case, we are trying to take two accounts. One is a bank account, like a check-in account or something. Another is more of a credit card account, where there is a swipe happening on your card. So if you see, like, Bob has an account, so you can see this particular bank account is owned by Bob. He lives at this address, and this SSN number belongs to Bob. Okay, so this is like, this is one set of nodes with the relationships. Similarly, Jim has this card account, a credit card. This card is also owned by Jane, and this is the SSN number for Jane, 1234. This card, as I mentioned, this is a joint credit card. So this is like a Jim also owns and at the same time, you can see, like, Jim has this SSN number 3456. Jim lives at this address. Looks like there is a credit card transaction that took place. So there is a card, because under one card account, there could be more than one card, let's say. So this particular card is being swiped at a merchant, which is located at this address. So looking at this graph itself, obviously, I mean, in the real world, you're going to have like, millions of nodes and edges. You're not going to be able to visualize the whole graph on a PowerPoint slide. But just to through the analogy here is like, if I have to look at this graph and try to humanly look for things like, which are really a red flag for me, I would say like the one thing I can see here, like Jim and Bob, they have the same SSN number, right? So they could be coming from different systems. Now you might imagine that if they are onboarded in the same environment, how it is possible that the system can allow you to punch the same SSN number? Obviously it's not, but what if like you have a different banking system and a different credit card system, and given that situation, there is a possibility that two different people are using the same social security number, right? And this is very common. I mean, you all know this. So this is one red flag to me looking at this data. Also, I see that, if you look at the credit card transactions, what has really happened is this card got swiped at a merchant, and this merchant is located at this particular address. Now, on this address, I see that the card holder, which is Jim, also lives at the same address, as well as the merchant also is located at the same address. So this tells me that there could be a relationship between Jim and the merchant, or the owner of this particular merchandise, or the business. I mean the shop, or the retailer per se. So this can create an additional link, right? So the link between Jim and the merchant doesn't exist, but since they live at the same address, or somehow they are located at the same address, now this could be purely a mistake in the data, but if this data is correct, assuming that the data is correct, I think there could be some kind of fraud happening here, where Jim has opened a card account and he's swiping the card at his own place to transfer the money out. And then, this is kind of revealed through having a common address here, right? So there are two scenarios. This is more like a fraud ring, and then this is like, more like a, identity kind of, sharing a common identity scenario. The second example I have here is about the insurance fraud. So again, this is a bit complex, but I'll try to explain this. So here I've considered two different policies, policy 123 and 456. This policy is, so there is a customer called Bob who owns like two different policies. It's quite possible. And looks like each of the policy has got a claim on it. So 456 belong to this policy. This claim belongs to policy 123. Also, there is a remark on this particular claim that it was a fake death. That means there is always already an investigation, or already kind of proved that this particular claim is a fraudulent claim. Okay. And this is more like a pending claim. That's the assumption I'm making right now. But we don't have any remark as such on this particular claim. So there is a possibility that since it's a common customer and both the policies belong to him and the claims belong to him, and one of the claims is fraudulent, so we may want to find the distance between different claims, and the claims are having the pending claim and the claim having some kind of fraudulent flag on it, like some kind of remark on it. So we can write a cipher query, or like a query which can give me all the paths which starts with a claim and which ends with a claim that has got a fake death. Okay. And obviously that's only possible. So let's say this policy was not owned by the same customer, a different customer, then obviously there will be no relationship. There will be no way you could traverse from claim 456 to claim 123, right? In this particular case, it's not many hops. You just go from claim to policy, policy to Bob, Bob to this policy, and so on. And that's how you come to know that this policy may have some connection with a fraudulent claim. Now, this claim may have a connection to some other fraudulent claim. Okay, so that's the first pattern I can see here. Second is I see that Bob was admitted in this hospital, and he was also consulting Jane. Looks like she's working at the hospital. Okay, so Bob is consulting to Jane. Now Jane could be very well working at the hospital, and hence Bob is consulting. So this may be an okay scenario. But then we see that Bob is living at an address which is the common address for Jane. So this could be like some kind of an insider transaction going on, where Bob is trying to admit himself fraudulently. He may not be sick, and then somehow since Jane is working there, she becomes like a beneficiary in this case, and they have a relationship that can be kind of determined through the common address here. So the fraud may be happening as a part of the hospital, but That may be the, that is what is visible here. But the relationship can only be proven by something that's common between them, like an address or a phone number or an SSN. So in this particular thing, we can see both of them are living at the same address, and hence there could be a connection between Bob and Jane, and they're trying to generate like fraudulent claims or getting admitted in hospital for no reason. Okay, so these are just one or two examples. This is just to build an intuition how graph visualizations can really help you. Now, to bring this kind of visualization, obviously you need to store the data in a graphical form in the graph database, so that you can navigate this kind of graph. You can run queries which are conducive enough to give this kind of information. If I had to write this kind of query in a SQL database and give me all the claims which are ending up in a fraudulent claim, I don't think so it's that simple. I mean, obviously you can write using a SQL, but it's not going to be very efficient. And when you're talking about millions of records, it's going to be much more difficult, right? So graph gives you both the power. It gives you the power of execution, and also it gives you the power of visualization. And combine the execution and visualization, I think we can crack the nut here, right? We can really look for these fraudulent patterns within your data, and then try to do a better job at detecting fraud. Okay, so I think we are at the end of this webinar. There are 2 other upcoming webinars in future. They'll be very soon, like probably one, each one of them after 15 days or 2 weeks each. We are going to focus on an insurance. So we are already working with a life insurance company where we are trying to implement fraud detection system using a graph technology. And also there is another use case which is about credit card, like how graph analytics can help you do a better monitoring and investigation with regards to the credit cards. Okay. So happy to take some questions now. Would appreciate if, I'm just going to look at my chat box. If there are any questions, then, I can respond to them. Okay, so the first question I see here is like, what kind of technologies we can use? How can we get started on a graph technology? So that is a question from one of our viewers or attendees. So what you can do is like, I would say the best way to start with, like, you don't want to get, caught up into the coding aspect of it, or getting too much technical into it. Rather, if you want to focus more on learning graph technology, I would recommend to use some kind of tool like Neo4j, which has, which can allow you to pull the data from your CSV. And then, so you start with a simple, flattened data set, and create like 2 CSVs out of it, like a node and an edge CSV, and then use these data sets to build all your nodes and edges. This is the simplest way to start with a CSV, and use a database like graph database, which is Neo4j. And then it also has an interface, nice interface, which we will demonstrate in our next webinar, which can allow you to quickly write the queries or drill down through by point and click. That's how it operates, So I think Neo4j is a good starting point for now. And then if you want to get into more scalable aspect of it, then we can talk about Spark and other things, at that point. But that would obviously involve coding. Okay, let me see what are the questions. So the next question is about the what kind of hardware is needed, like to scale out a graph technology or a graph algorithm. I mean, I would really say that it's not really. I mean, you can use a commodity hardware to run any kind of graph database or technology. That's not a problem. I think what power of hardware is needed, that's important. Like how many servers you need, whether the algorithm that you're trying to run, is it a distributed algorithm or a vertical scale algorithm? So the choice of software is more important than the hardware here. And then depending upon the software, obviously you'll come to know whether you need, whether you can run the software on one machine or you need multiple machines. But there are many algorithms which are very distributable in nature. So you can choose one of those things, like, like as I said, so you can use Spark, because whatever Spark tries to do, whichever algorithm they try to implement, they implement in a very distributed fashion. So if you were using Spark, no wonder you'll be working on a distributed hardware where you have multiple nodes executing at the same time, so that you can reduce your overall time of execution. Okay, but again, if you're just getting started with this, I would recommend you can just install Neo4j on your laptop and not worry too much on the hardware at this point. When the scalability aspect comes, you need to focus on, because your technology your graph as a concept can still remain the same. You just need to find a better software which can help your graph analytics do better, like a different type of hardware. I'll take one other question. So there is one question from the audience. This is regarding the number of nodes and edges. Like, what are the limits on it? Um, I would say, I mean, as such, we have not personally experienced any hard limit on the number of nodes and edges. I think it totally again depends upon your hardware software capabilities. But we have worked with graphs which are where we are talking about like 100 more than 100,000 nodes and millions of edges. So I'm talking about a database where we had almost like 250,000 customers, or you can say policies, and then from an insurance world, and then obviously there were like millions of edges around those nodes. So performance is going to be obviously a question when you're dealing with such a big graph, and that's where you will need something which is more scalable hardware and more horizontal scalable architecture from a software and a hardware perspective. Okay. Okay, so what we can do is like I would say the next and I welcome all of you to join our next webinar. Let me go to the next last slide. So thank you very much for joining us for this webinar. You have our email ID, the website, and the phone number. Feel free to contact us if you have any questions on or any interest with regards to graph analytics. We are happy to help you, conduct a POC. We have extensive experience in it. And, after the POC, obviously we can make a decision with how much applicable it is for you and how much beneficial it is for you. Even if you want to like to have a quick chat with us, we are open for it. You can reach me out or through my LinkedIn, or you can always contact us on this number, through this number. Okay. Thank you very much.